Good evening, everyone, and welcome to our webinar review of the December 23rd, 24th storm. We will get started in just a few moments. We'll let people catch up here as they get set up this evening, and we will get started soon. Thanks, everyone, for joining, and we hope you are looking forward to this review of the event. All right, good evening, everyone, and welcome to those who are joining in. We're happy to have everyone here as we start this webinar review of the storm that took place on December 23rd and 24th of just this last year. This is Robert Haynes here at the National Weather Service in Burlington, and I have Rodney Chai with me as well. We'll be going over this review, and I'll take about half of it, and Rodney will take the second half here. So thanks everyone for joining. We do have a question tab that you can use on GoToWebinar. And as we go through the presentation, feel free to leave some of your questions in those tabs, or if you have any other comments, you can leave those there as well. And of course, once we wrap up this session, later on our YouTube channel, we will post the recording of this if you'd like to refer back to it later. So without further ado, let's get started on this review. So here's the outline of the things that we'll be talking about tonight. We'll discuss what made this storm a big event. I think we can safely say it was a fairly large event, both in terms of the scope of the impacts experienced and some of the numbers that we saw out of this event. We'll look at a few of the forecast elements to this event, how things transpired and how we got such strong winds, such heavy rain, as well as the lake effect and blizzard conditions that ensued as the storm lifted to the north. And we'll take a look at a little bit at the communication side of the forecast. It's not every day that we deal with such high impact weather events here, and so we'd like to discuss how we ramped up the communication as we headed into this event. And then finally, we'll discuss a little bit about what happened as this event took place. So that'll cover the complete package of what we hope to discuss tonight. All right, so let's talk about what made this storm a big event. So here's by the numbers what we saw with this event. In a lot of cases, we just have one headline, say a flood watch or a winter storm watch. In this case, we had three different types of headlines that we were juggling. We had flood products out, we had the high wind warnings and the wind advisories, and later into the event, we had the blizzard and lake effect warnings out as well. This event also produced several thunderstorms across the area. There were 49 reports of thunderstorm wind damage or gusts in thunderstorms greater than 58 miles per hour. A lot of the region saw 3/4 of an inch of rain to about 2 inches of rain. Despite all of this heavy rain, there was only one rain record that fell on December 23rd, and that was 1.18 inches at Plattsburgh, New York. We saw the second highest reported wind gust of 71 miles per hour at the Burlington Airport, beating out the Great Appalachian Storm of or not quite beating out the highest, which was 72 in the Great Appalachian Storm in November of 1950. There were numerous outages, peaking at over 70,000 customers without power across Vermont, and our temperature reached 56 degrees Fahrenheit on that day, December 23rd, melting the snowpack and contributing to the river flooding that we experienced. Other notable things, as the cold front passed, we saw a 34-degree temperature drop in 6 hours at BTV. That would be about the third highest during meteorological winter in that time frame. This would contribute to the flash freeze conditions we saw as the cold front passed through. We had about 5 reports of minor river flooding and 1 ice jam that formed as a result of this event. 37 inches was the highest total from the lake effect snow measured in Gouverneur, New York. And then we saw less than 1/4, and what that was is the visibility values experienced in Ogdensburg and Messina between December 24th and 25th, even at least just for 6 to 12 hours, along with gusts over 40 miles per hour. And then widespread 5 below 0 to 20 below 0 wind chill values were experienced on the 24th after so many lost power. So a lot of these different meteorological hazards came together in such a way that the effects of, say, the wind had a downstream effect to the vulnerability to the cold temperatures that were experienced the following night. So quite a few weather hazards came as a result of this event, and several of them played a part into making other hazards a little more significant as well. So here's a few other by the numbers things. How unusual was this event, and how often do we see these kind of events? One of the things that we can use when we provide our weather forecasts is take a look at the statistical perspective. How much do the numbers that a specific model turns out, how much are they compared to other events? So we have the capability using ensembles or weather reanalysis, or some will call them reforecasts, can tell us how unusual an event is compared between model and model, a variety of different events. So what they're telling us is, once all the math and all the calculations are done, how do these numbers relate to past events? Now, the number of years behind this can vary. Usually with these kind of these period of records, it's about 20 years. So in other words, what we're here looking at in these two maps, in this area of deep purple, this is the minimum amongst these reanalysis for any of these 20-year events. So in the last 20 years, all models at all hours have not seen pressures this low. Another measure of this, the extreme forecast index, telling you how far in a distribution compared to certain events a forecast might be. And you can see that the forecast along the greens and parts of the Northeast Kingdom as well, we're sitting near the extremes as well. So we had multiple sources of agreement just in a statistical range, telling us that this was going to be a larger event than usual. And so when we kind of put this in perspective as well, we talk about the winds and how they compare to what we've seen in the past. We had winds at 850 millibars, which would be about 4,500 feet above sea level, sitting at our highest mountain summits, forecast to be about 90 to 100 knots, or 105 to 115 miles per hour. Forecast numbers like this had not been seen since the high wind event that occurred on October 30th and 31st of 2017. And several forecasters had noted, even those who had experienced many events, they had not seen numbers this high. Here's the map of the big October 2017 event for scale and comparison. So you can see there's some differences here. We'll pull out the pen tool here really quick. You can see some differences between where the exact area of, we can see the exact location of where the low is. So there's some slight differences there. And you can also go back and see that this low is perhaps a little bit more broad as well in nature compared to the more compact event that happened in October of 2017. Nevertheless, you can see both featured very high winds focused along the spines of the greens as well as the eastern Vermont. But due to the different placement, a larger part of our area was under threat of these strong winds compared to the October event, which primarily focused across Vermont. And so then let's also talk about some of the other unusual things that took place in this event. We had lightning across a good portion of our area. About 7 a.m. on Friday, we would see some lightning strikes in the southeastern Windham and Windsor County areas near Springfield. And by 7:40, there was one little blip there just west of Burlington. And we'll see additional flashes and strikes of lightning across northern New York during the day on Friday. Lightning is pretty uncommon here in the month of December, and I have these charts of our lightning climatology to kind of demonstrate that. If you've ever attended any of our Skywarn courses, we'll tell you that our peak season for severe weather is June, July, and August, and you can see the concentration of lightning surrounding June, July, and August. And then as you go through the periphery months, you tend to find that there's not quite as much lightning. While not unheard of, you can see that at this point of the year, in December, where I have the arrow pointing, it's very uncommon to see flashes of lightning during this point in the year. And then here's for, oops. Oh, I guess it's, there we go. For Clinton County, New York as well, you can see that it's a similar picture as well for the lightning that took place near Plattsburgh, New York, and then areas west, generally quite uncommon in Clinton County as well. All right, so we've discussed a little bit about by the numbers of why this event was as unusual as it was. Now let's dig into some of the forecast elements behind this event. So here we have an upper air map. This is something that we meteorologists use to find systems where areas of low pressure, high pressure are. We look for areas of interest. Marked here in the X would be the shortwave trough. So you have this upper low position here, and embedded within that feature, you have this smaller scale trough that would be of interest to our area. So this would be at 7 p.m. on December 22nd. So this is our earlier disturbance. And then by 7 a.m. on December 23rd, you can see it rounding up into the upper low and head towards our area. A few key features to note here on this map. So this is about 18,000 feet high in the atmosphere. A few key things to note is the orientation of the trough. We see that it's oriented northwest to southeast, and that's usually very favorable for providing this area of upper defluence here. These areas where you see southwest winds then turning into the southeast winds as you get towards areas like Nova Scotia. This is very good for moisture transport out of the Gulf of Mexico and the Atlantic Ocean. It's also very efficient for helping just the ascent of air into our area, very favorable for heavy precipitation across our region. So from these maps, we were seeing a few of these different details that would point to at least a very high end event for the moisture content. You can see it's very amplified as well, just with the proximity of this upper low to the high. And you can see that the ridge builds in strength and intensifies along with the area of upper low pressure. As we get down towards the ground, we can see we had two different areas of low pressure. We had an area of low pressure near the mid-Atlantic coast and another towards the Great Lakes. Over time, what took place was this second low pressure over the near the mid-Atlantic coast that began to take over, and that one was the one that really took off. We started to see it quickly deepening as we headed towards 7 a.m. on December 23rd. So for those waking up, you can see these little areas of 3 pink dots or 2 pink dots. That's indicating heavy rainfall. So we see this area of the warm front lifting north. Before the warm front lifted north, we didn't really have as much of that mixing, but then as you get into that warm front, you can see the stronger wind gusts by the number of flags that each of these different little lines or notches have here. So the more notches, the windier it is. And so once this came through, we saw the strong winds across our area into the early afternoon hours. And then what would play a part once the cold front went through, we had the flash freeze conditions. So you see right here's Montpelier. I'll kind of highlight that. So you can see Montpelier here had about a 50-degree temperature reading. And then 5 hours later, just a temperature reading of 29 degrees. So a very sharp cold front that played its way through the area. And then following that, with the track of the low up towards James Bay in Canada, we had persistent southwest winds here in the St. Lawrence Valley. And the persistence of these southwest winds and how strong they were would result in the persistent lake effect band and the blizzard conditions that we would see near the St. Lawrence River. And then, of course, we've already highlighted the strong winds at 850 millibars. And for reference, these high winds verified. It helps to have these strong winds aloft to make it down to the surface and to produce these gusty winds. Strong pressure gradients can help. And the fact that we had 850 millibar winds of 100 to 110 knots was verified by the fact that we saw Mount Mansfield gust to 130 miles per hour on this day. So here were some of the warnings that we had. So we had the winds at 4,500 feet, about 105 to 115 miles per hour, such that we hadn't seen since October 30th and 31st of 2017, keying us in on the idea that this would be a high-end event. So we had warnings across a broad section of Vermont, and the main locations that we focused on were some of the downslope regions, especially of the western side of the Greens and then the northwestern side of the Adirondacks. These areas are particularly prone to downslope winds. And so figuring how favorable these conditions are to produce such strong winds was a big forecast consideration to the high winds that we were expecting on that day. Ideally, you want winds that are roughly perpendicular to the mountain range. So a southeast wind is perfect for producing the strongest winds in these locations. So the strong southeast flow that was observed at 850 millibars was right in line in the most climatological favorable conditions for this area. So what ends up happening downwind of these mountain ranges, you develop these very small scale atmospheric waves just downwind of the mountain ranges. And once they break, and if you have an atmosphere that is well mixed, you get these strong winds that will rush to the valley floor. And so in combination with this, you see we have the strong winds aloft. So then it becomes a question of how favorable are the mixing conditions to produce strong winds down into the lower valleys. We look at these features to determine whether or not the winds will be confined to summit level, or will it make it all the way down into the Burlington area. And so you can see we had the expectation that these strong winds would mix down into the Burlington area, but you can see we had a small sliver of the western Champlain Valley on the New York side without any products or without any wind headlines, because we thought the mixing potential, while good, was not good enough to make it all the way across Lake Champlain and into parts of far northeastern New York. So what do I mean with the potential for mixing? We look at how the temperature transitions as you head higher and higher into the atmosphere. So we look for where temperatures start to increase with height. So areas where you have temperatures warming is an inversion layer. And what that typically does is it acts as a layer of stability that will prevent winds from mixing further down. So the height of the inversion is important as well, as that corresponds to whether you can get atmospheric waves to develop at these ridge tops and then break. So the fact that we saw the height of the inversion sitting right around 4,000 feet is right about the summit levels for many of our Vermont mountains. So this was quite favorable. The one thing that was somewhat in question was the level of mixing. While sometimes models can overdo it by overestimating the amount of snow depth on the ground, as we saw in this case, the winds were so strong that by the time you even reached as close as 2,000 feet, you still had models accurately indicating these 70 to 80 knot winds, which would translate to about 80 to 90 miles per hour. So we saw very strong evidence supporting very strong winds, even in the lower valleys. Again, we've drawn a few comparisons to the October 2017 event. So for comparison, here is one of the forecast soundings for Burlington in relation to that event. And you can see about 5,000 feet. The winds were actually not quite as strong in this event. However, the favorable low-level lapse rates were a little bit more suitable to mixing in that event. Nevertheless, the overall greater strength of this event here, I think, lent itself to such strong wind gusts observed in the valleys. So very high winds observed due to these conditions. And then the next thing, of course, to note were the lake effect conditions. The strong southwest winds would result in areas of snow accumulations of 4 to 12 inches with localized higher amounts. And due to the placement and how deep this area of low pressure was, we saw pressure values bottom out at 964 millibars, again, near climatological minimums. So as a result, the wind gusts that we saw were strong and persistent. And as such, we felt confident that we would be able to see blizzard conditions, especially in and along the St. Lawrence River. So places like Ogdensburg were most impacted by this event as we went through. And something that's highly unusual for our area, this was the first time that our office had issued a blizzard warning since the Pi Day storm, also in 2017, where we'd also end up observing our second highest snowfall total. So it had been nearly 5 years since our last blizzard warning when we issued this one for the St. Lawrence Valley. So just to quickly clarify what a blizzard exactly is, it's based on these 3 different criteria, and it's actually quite stringent, and we do strong quality. So we do all of these different quality checks and then verification to determine whether blizzard conditions were observed. What we look for in the forecast is either blowing or heavy snow. I shouldn't say or, I should say and. We look for blowing snow and with that 35-mile-an-hour winds, and that can also be expressed with frequent gusts and whiteout visibilities at less than or equal to 1/4 of a mile in terms of visibility. And we look for this to last for at least 3 or more hours in the duration of an event. So from this expectation of how long that we expected the winds, having the lake effect snow in place, we were very confident that we would see all of these events together, especially near places like Ogdensburg. All right, so that about wraps up my portion here, talking about the high winds, some of the forecast elements, how unusual this event was in terms of the numbers that we saw, as well as some of the meteorological details and processes of this event. Before we head into the communication side of forecasting this event, are there any questions out there? I'll pause a moment here to take a look at the question bar. If you have any questions, feel free to enter them at this time. All right, I'm not seeing any questions at this moment, but we'll go ahead and continue the presentation. Just know that you can enter any of your questions into that little question box, and we'll get to them later. At this point, I will pass it off to Rodney, and Rodney will talk about the communication side of the forecast and go into some of what we observed during this event. So here I pass it to Rodney.
Well, thank you so much, Robert, and thank you so much, everyone, for joining us on a Saturday afternoon. My name is Ronnie Chime. Recently joined the office from the Boston office, actually, last month. So I'm very happy to be here in Burlington. Very happy to get to know all of you. So let's take a look at the communication side of forecasting after we did a deep dive into the meteorology. So this is a winter storm timeline infographic that some of you might have seen on our social media page. And you can see that this graphic, we put out this graphic just because this is really a multifaceted event with multiple weather hazards that would take place at different times for different locations. So just having this graphic kind of summarize some of the more pertinent points, and so in the hope that folks would be able to take actionable contingency plans to ensure their safety during this prolonged winter storm that has such a high impact across much of our area. And so we try to the National Weather Service, the mission, the primary mission remains to provide the timely and accurate forecast to safeguard life and property. But increasingly in recent years, with the new National Service Director, Ken Graham, we have also increasingly emphasized the importance of, ensuring that folks are weather ready and ensuring that we have strong collaboration with our partners, especially the emergency managers. So this kind of graphics help us to ensure that we provide the best possible service in addition to providing the best possible forecast. So and feel free in the in the Q&A or the comment box, feel free to let us know what you think of this timeline, what is good and what can be improved upon, and we are always very open for feedback. And here's another graphic that you might have seen. So this was to illustrate the flash freeze. And in a few moments, I would give you the official definition of a flash freeze. But essentially, it's basically temperatures falling rapidly below freezing. So in this case, it was from the 50s into the 20s in just a few hours. So, and you can imagine after all the rain that we have received, more than an inch in many locations, with such a rapid drop in temperature, you can cause different problems for commutes and travel, and especially because this was right before Christmas as well. And this is the definition of the flash freeze. You can see here. So wet roads can freeze quickly at night or when there's a rapid drop in temperature behind a sharp cold front. And of course, here are some of the kind of like common sense safety tips, but still important to bear in mind. Slow down and leave plenty of distance between you and other vehicles. And as the event drew closer, as we became more confident of the magnitude and the timing of the falling temperatures, we began to put out more, in our terms, deterministic graphics. So deterministic means that we kind of hone in more on the numbers to give folks a better idea of what to expect. You can see, so in this case, at Friday 1 p.m., you have, temperature really dropped to below freezing across New York State, but still well into the 40s and 50s across Vermont and New Hampshire. And then as the day progressed, as the evening approached, temperatures dropped like a rock. And this is just a different way of communicating the same thing, but hour by hour. And we put in some of our towns and cities, and obviously we couldn't put in every single town, otherwise this would not be readable. So, but we did try our best to put in some of the more popular, more populous towns and cities. And likewise, feel free to give us your comments and feedback about such graphics. How did it help you? Did you feel that it could be improved? And the other thing was, besides the flash freeze, was the high winds that Robert talked about at length. And this was the wind gust forecast. We tried, and this really, from our point of view, it only made the most sense to put it out kind of like the day of or within 24 hours, because obviously when you provide hourly wind gust forecasts, they can change. And you really shouldn't take it verbatim, but kind of take it as an overall trend when you can expect the highest wind gusts. In this case, it was pretty clear that it will be during the morning hours, from anywhere from 6 a.m. to 10 a.m. In the Lake Champlain area, and down to Montpelier. And you can see, and then from Friday afternoon onwards, you can see kind of like a resurgence in the wind and the southwest wind that Robert talked about, just because of the how the storm evolved with the low pressure. And you might have heard of the term bombing out to our north. You get the prolonged, just strong southwest wind that kick-started the lake effect machine for our New York State zones. You can see places like Messina just gusting 40 to 50 miles per hour for like 12 or more hours. And bear in mind that the definition of a blizzard was 3 hours of 35 mile per hour gust with whiteout conditions. So the St. Lawrence County locations easily surpass the minimum blizzard criteria. And the gust even continued into the weekend, into Christmas Day. And you can see by Saturday night, Christmas Eve night, the wind, they fell below a wind advisory criteria. And the wind advisory criteria, it's about 40 mile to 49 mile per hour gust. And clearly this is below that, but our emergency management partners have told us that, when you have power outages, you see the bucket trucks around, and those bucket trucks, they have to stop their operations when the wind gusts above 30 to 35 miles per hour, because it's just too dangerous for the workers to restore power. So even if they want to restore power, even if you think, it's like clear skies, but it's very gusty conditions, it might take a while, despite the best efforts to restore power. And of course, we have the cold wind chill values, not out of the ordinary for for our area in winter, but still this was the first really cold temperatures for the area. So there's some concern especially for the utility workers trying to restore power and the homeless population. This could be dangerous. And just take a look at the lake effect component. You can see here our snowfall maps at different scales. The more regional scale on the left-hand side, and then on the right-hand side, as we transition from the multi-hazard event into a primarily lake effect and blizzard event for St. Lawrence County, we decided to put up graphics that really zone in on St. Lawrence County. You can see here, for the folks joining us from New York State, we try to provide a more zoomed in version of what are the snowfall accumulations you can expect. And moving on to what actually happened during the storm. And as Robert talked about earlier, we saw a maximum wind gust of 71 miles per hour here at the Burlington International Airport, BTB. And and also near the summit of Mount Mansfield, about 4,300 feet, it gusted up to 130 miles per hour. So that was really consistent with when we saw the 850 millibar winds, which is around 4,500 feet, 105 to 150 knots. So that pretty much verified the models at that altitude. So you might have a question like, okay, so why did Burlington gust up to 71 miles per hour? And then, that's kind of stands out in on this map right here. So we did have this discussion in the office, and we talked to some of our partners, and I think so. What happened was, a lot of these sites, they are automated. They are electronic weather instruments, and there were widespread power outages with the high winds. Now remember, the first surge of the southerly wind came in kind of around pre-dawn to early morning hours. And at that time, the number of power outages, and I will show you in a little bit, they were increasing almost exponentially. And so now when you lose power, and if you don't have the backup power for the weather instrument, they will stop recording the wind gusts. So in this case, just again, a hypothesis is what happened was that here at the airport, we had backup power, and so the weather instrument continues to record wind gusts, but some of the other sites, they were not able to stop recording. So those were the numbers that they hit prior to losing power. So in this case, you kind of have to take this map with a grain of salt, but the idea is that there probably was widespread 60 to 70 mile per hour gusts across the area that led to there's over 70,000 customers without power at its peak. And here you can see that from Green Mountain Power, you can see the number of customers without power peaked at over 70,000 people. And even, as the day progressed, as we got into Christmas Eve, the number remained stubbornly high because, the winds were continuing to blow, and the utility companies were struggling to use their bucket trucks to restore power because of the continued blustery conditions. And here you can see just a different depiction by areas. You can see the orange and the dark orange colors represent areas that have a higher concentration of customers without power. And here are some of the pictures that from social media and from some of you, just showing the damage across the area. And typically you would see such damage, maybe after a severe thunderstorm rolls through in the warm season, but not so much when there's actually snow on the ground. And here's you can see a really nice picture, of a rainbow as the first phase of the storm wrapped up, and as we awaited for the flash freeze. So you can see here's a really cool satellite image showing a small area of clearing, within a sea of clouds on satellite imagery. So moving on, so we kind of have like a respite, if you would like, in hazardous weather. After the morning round of high winds, temperature jumped into the mid 50s. So it's unbelievable for 2 days before Christmas. And then the flash freeze came about. It was well advertised. From west to east, temperatures dropped like a rock from the 50s into the 20s. Now, as that happened, what happened was, this is like, so we obviously had a strong cold front, and as the cold front progressed through the area, it left a frontal boundary. And so basically it's a dividing line between two very distinct air masses. So you have the warm, moist air mass being shunted to the south and east, and then you have the cold, dry air mass behind the Arctic cold front. So what happened was a wave of low pressure, a weak low pressure developed along this frontal boundary, and it led to an era of snow that blossomed as it lifted from south to north. And typically the cold front, it usually would be from, northwest to southeast, but in this case, it actually lifted from the southwest to northeast. So you can see, we just wait for this loop to go back to 4 p.m. here. So here you go. So focus on the area. So here, where it turned dark green and yellow. So the dark green and yellow color represent heavier precipitation rates. And this is pretty much all snowfall for our area. So some of you might remember, if you are out and about at 6, 7 p.m. in the Burlington area, you might be, besides the cold temperature, snow started falling, picked up in intensity. There was, probably it was blowing pretty hard, fluffy white stuff, accumulated 3 to 6 inches in just 2 hours, and then it just lifted into Canada. So the good thing was that it ensured a white Christmas for our area. And so you can see some of the pictures that we received from social media. You can see that the snow just stuck immediately because the temperatures were so cold. And the temperature profile of the atmosphere was ideal for the fluffy snow that we saw. And because of the high fluff factor, basically it's kind of like there's a lot of air spaces within the dendrite. It accumulated very efficiently. So it was actually like 2 inches per hour snowfall rate. It did lead to some inconvenience and some accidents, but for the most part, it made for a white Christmas. So here are some of the snowfall reports that we received. You can see a pretty good area of 3 to 6 inches, lesser amounts to the south and west. And here are some of the wind chill values that we recorded across the area. So basically widespread -10 to -20 Fahrenheit wind chill values. So wind chill values basically is a function, it's a combination of the actual air temperature and the wind speed. So obviously the higher the wind speed, you will actually feel colder than the actual air temperature depicts. And here's to take a look at the lake effect and blizzard conditions across St. Lawrence County. And you can see, and don't focus so much on this is from the automated sensor, weather sensor. Don't focus so much on the light snow. I can tell you that from the visibility you can see here, so the 0.25, that's quarter mile visibility. So basically you have like 12 to 18 hours of continuous low visibility. It is obviously not light snow, it is heavy snow with winds gusting 35 to 40 miles per hour. And you can also take a look at this column here, that's the wind chill value. So you can see, all the minus single digits to -12, that's wind chill. So for example, you have actual air temperature of 9 degrees coupled with a wind of 23 miles per hour that led to a wind chill value of -12. So I can just draw here and see. Here we go. And this is just an observation from a specific hour. So that's Christmas Eve at 7 a.m. in Ordensburg. And then likewise for Messina, you can see very similar, if not, the winds is a little bit higher, 40 to 50 miles per hour. So bottom line is that we had 24 to 36 hours of continuous blizzard conditions, in addition to the cold temperatures and heavy prolonged lake effect snow. So if you live in St. Lawrence County, you had a very pretty high-end lake effect and blizzard event as well. And here's the observed snowfall total. And you can see basically we have localized 18 to 24, and you can, there was a 37-inch total towards western St. Lawrence County. So a pretty high-end event. And to top it all up, we actually had very localized flash flooding. So we talked about the heavy rain, but there was also the temperature surged into the mid 50s, and that helped to melt the snowpack. And so a combination of the warm rain event and the melting snow led to area-wide rises in river levels to minor stage flooding. So some of the more vulnerable low-lying areas witness minor flooding. But you can see so widespread, at over a 48-hour period, there was a widespread 1 to 2 inches of precipitation. And there was we had a very localized ice jam as well in St. Lawrence County, so actually just south of Potsdam. And we actually issued a flash flood warning for because there was some homes that were actually evacuated because of the rising floodwaters from the ice jam. So this is the last slide. Thank you so much for your time today. Thank you so much for attending the webinar. We hope you enjoyed it. So if you have any further questions that we don't answer in the Q&A that's coming up, feel free to email either one of us. My name is Rodney. You can also email Robert as well. And then after that, you can also access the recorded webinar on our YouTube channel. And so now we'll transition over to the question and answer.
Yeah, let's start looking at some of the questions that we have posted. I saw one. Let's go up to scroll up to the first question that we saw. We had one question here, and then thanks for all the comments and responding to Rodney's call about some of the recommendations on the social media posts. We'll start with this first question about our southwest wind gusts like this uncommon, and why would they be any more destructive from winds in any other directions? So what this kind of points to, sometimes what we see with these systems, sometimes we'll simply have a strong southeast component to the wind gusts, and then after the front crosses, the winds typically will often dissipate. But with these strong areas of low pressure, especially when they move north of us, we get a second round of strong southwest winds, which is what we saw at places like Messina, New York, and into Ogdensburg that kept these blizzard conditions going. Now, especially with our climatological wind directions, sometimes we talk about our trees like they develop muscles to prevailing wind directions. So some trees will be used to these strong southeast winds, and so they'll essentially develop a muscle against strong southeast winds, but they might not develop it against a southwest wind. And so when they're faced with these different wind gusts from a direction that they're not as accustomed to, they can be a little more destructive in those instances. So in a southwest wind in the St. Lawrence Valley is relatively common. And in the western slopes of the Greens, a southeast wind might be a little bit more common. Nevertheless, the wind gusts were so strong that it didn't matter how much of a resistance that these trees had built towards these wind gusts. So with that, we saw such widespread reports of damages just due to how strong they are. Some uncommon wind directions for us, we don't often see very strong, we don't see winds of this magnitude, say from like a northwest or a north or a northeast wind. So if we saw these kind of winds out of those directions, there would certainly be more issues related to that as well. And then I saw another question here that we can highlight. The labeling of these events as historic or once in a generation. How do we classify these events and their relation to climate change? How do we look at these events going forward? As far as what we do, we can communicate a lot of these extreme forecast aspects, like we showed how statistically models do not put numbers of what we saw out, and that can help us message. As far as attributing the role of climate change, our state climatologists will go into detail, and they'll be doing their own analysis of this event as well, to look at how climate change may have impacted this event. Now, November and December are often the windiest months, especially kind of transitioning into winter. It is a windy time period, climatologically speaking, but the numbers that we saw were on the higher end. So the questions that we'll be looking at as we continue our analysis of this event will be, were like how much of what we observed was a result of climate change, or how much of it sets normal to our climatology when dealing with these kind of events. So that would be that. With that, would you like to take the next few set of questions, Rodney?
Sure.
All right.
This one.
Yeah.
Okay. So we have this question from David, who's a Skywarn spotter. So thank you for being a spotter. So David asked, so he said in Waterbury Center, the power went out at 8:30 a.m. on Friday, so December 23rd. It didn't come back for 54 hours. And I couldn't get off my road to get a cell signal, so couldn't report to you. But we had 40 trees down along my 3.5-mile road alone. So definitely exceeded 60 miles per hour here, but my weather station was down the whole time. So thank you, David, for that for the information. I'm sorry that you lost power for such a long time, but thank you for your report. And that goes to show that the wind gust graphic that we put out there, it might not actually be totally representative of what actually happened or transpired in real life. So in this case, that's really good kind of a confirmation that there were some very high winds in the Waterbury area. So the next question is also from David. So on that one slide, would that be Vortex? So I guess just can try to
Yeah, that's slide back to it would be somewhere in like the 15 or so area. So it would be back of the analysis. So yeah, so what are we talking about when we talk about vortex? Because it's a little bit of a meteorology jargon there. So what we describe with vorticity is what's called the curl of the wind. So high wind speed and then the wind shifting direction over a small distance would highlight where you have high values of vorticity. So yes, that X is marking where that tiny shortwave that was embedded within that upper low that would play a part in the rapid development of the cyclone would be. So yeah, that would likely be where the vortex was located, although vorticity values aren't shown on this map specifically.
Yeah, so I just add briefly that so this vortex is vorticity max. So now remember, this is at 18,000 feet, so way above the surface. And so if you go back to meteorology 101, the whole idea is, you have warm air rises leading to rising motion of air that eventually leads to storm formation. So at the low levels, you want to see what we call kind of a low level convergence of air. So, when you have air mass that is converging, it has nowhere to go but upward into the atmosphere. Now at the 18,000 feet level, kind of think of it like a ceiling. So if you have a strong jet of air that is directed upwards towards the ceiling, now the ceiling acts as an obstacle, a barrier for the upward rising motion of air. And what happens is it diverges. So basically, so you have the low-level convergence, upper-level divergence. It leads to a cycle. So what is happening here is that you are seeing, with this vortex, you are seeing evidence, or is inducing what we call an upper-level divergence over our area that would in turn lead to a rapid rising motion of atmosphere near the surface. And that is part of the explanation for why this storm rapidly intensified, because it had all the ingredients for it to do so. And because we have a rapidly deepening storm, and as Robert mentioned, the pressure dropped to nice 64 millibar. And, the media talks about, the bomb cyclone. It is a meteorological term, but of course the term itself gets people excited. The bombogenesis basically is rapid deepening of a low pressure system. And the criteria is the pressure drops 24 millibar in 24 hours. So in this case, that was surpassed easily. So when you have such a strong storm system that was rapidly deepening, along with the strong vorticity maximum, it leads to all kinds of high-end events at the surface. In this case, the high winds, the flash freeze, and I would say high-end lake effect and blizzard conditions in St. Lawrence County. So great question, and thank you. So,
I can take this question here from Jonathan Bassett. How did the high wind event compare to other events in the last 10 years, say like Hurricane Irene? Yes, we will be doing a write-up, and thanks for listening all the way from Texas. I did pull up this old slide that we have from an old event. So this isn't, the photo is going to say this storm, but it's not this December 23rd to 24th event, to show you some of the GMP outages as reported by WCAX3. So with that one, we had about 125,000 outages in the October 2017 event. There was another in 2014. I believe this was a heavy wet snow event that produced about 145,000 outages, and Tropical Storm Irene at about 140,000. So this event, not quite on that scale. And I'll also note that this slide does not include the heavy wet snow event that happened the week before, and that event itself also topped this event as well. So I think this event ranks within the top 10, but I think it ranks as number 7 or 8. And in the last 10 years, we have had some events that have produced slightly more in terms of the overall outages of the event. So certainly on the upper echelon, and it doesn't quite compare to the Irenes or the heavy wet snow events of 2014, but it'll certainly be remembered, especially for the amount of property damage and tree damage that it did. Thanks for the great question. All right, not seeing any additional questions. We'll go back to the end slide really quick just to get you back to the contact information that you can reach us at, and of course our social media pages and our YouTube channels as well. So these are some of the ways that you can reach out to us for your additional questions. We'll hang on just for a little bit longer just to see if we have any lingering questions out there. But wanted to also just reiterate my thanks as well to everyone for listening in and joining. Do you have any last notes, Rodney? All right, so thanks again for the messages here. We have is Tuesday a repeat of this? No, the upcoming system that we see down the road will not be quite as impactful as this one. So, and yes, we see all the hope for snow out there. We are certainly lacking for snow depth at this point of the year. So we'll hope for some events down the road, but we still might have to wait a little bit longer as the 1 to 2 week outlook continues to look quite warm for our area. All right, we will go ahead and wrap up the presentation here. Thanks everyone again for joining us. We'll have another session for those who missed out on Tuesday from 7 p.m. to 8 p.m. And again, feel free to contact us or reach us at any time. Thanks so much for joining everyone, and hope you have a wonderful evening.